So the very basic forms of factoring that we've discovered when you factor a quadratic trinomial, such as this, is a simple method because of the fact that there is no coefficient spoken. So there's the coefficient, the leading coefficient, is only a 1. And because of this fact, when you unfoil or factor, the only possible combination of terms that multiply to give you the first term are x and x. What we are going to be doing now is we are going to be discussing what happens when you do have a leading coefficient. So the leading coefficient is more than just 1. For example, if I had, and before I begin the actual lesson, I want to give you an example. If I had something such as 2x plus 3 binomial being multiplied to 2x minus 1, or let's change the 2 so that it's not repetitive. Let's say 3x minus 1. What you would do when multiplying, these are the factors because they are the two items that multiply to give you a product. What you would do is you would multiply the first term of the parentheses times the first term of the second parentheses. And your first term would end up being 6x squared. Then you would multiply, either through distribution or through FOIL, the outer terms. That's these two on the outside. And when you multiply 2x times negative 1, you get negative 2x. Then you would go to the inner terms, which would be the 3 and the 3x. And when you multiply those, you get positive 9x as your inner term. And then lastly, you multiply the last term times the last term. So the last term of the first parentheses times the last term of the second parentheses. And that gives you 3 times negative 1, negative 3. From there, you would notice that you would be able to combine the middle terms, and you would be given 6x squared. The outer and inner combines to give you positive 7x, and then the last term is just negative 3. What you're going to be doing with factoring quadratic trinomials is that now you are going to be given a quadratic trinomial where the leading coefficient isn't just 1. So if I was to try to figure out, working backwards, how I can go from 6x squared plus 7x minus 3, if I'm working backwards, and I'm asked to factor, and I don't have the original two binomials that I did above, I know that I am going to still have two parentheses, two binomials, something, binomial times a binomial, and I'm still going to think about the fact that the first term multiplied by the other first term together give me 6x squared. The problem, however, is that there's more than one combination of numbers that multiply to 6x squared. You could have 6x times x, you could have 2x times 3x, and you could actually have a different order, 3x times 2x. So, since there are multiple ways of, or multiple terms that would multiply to give you 6x squared, your job is to try to figure out how to go from this trinomial backwards to this term before you combine like terms. And then from there, you notice that there are 4 terms. You would be able to group the first 2, group the last 2, and factor. So the process itself actually follows the following steps. The first thing that you have to do is try to figure out what this middle term actually expands out to. So you're working backwards. And the way to do that is by asking yourself, what numbers add to 7, but you also have to take into account this 6. So there's a little saying that often is used to help you expand out the middle term. And that saying is you need to find the product of AC that sums to B. What does this mean? Going back to a standard form of a quadratic trinomial, ax squared plus bx plus c is the form. So when they ask you to find the numbers that create the product of a times c, your job is to find what multiplies to a, which is 6 times negative 3. So what multiplies to negative 18 that adds to b, which is 7. It adds to 7, positive 7. From here, what you're going to do is you're going to think to yourself, well, if the product has to be negative 18, product of AC, so product of 6 times negative 3, that sums to B, that sums to 7, then you're going to go ahead and find the factors of that specific 18. So what numbers multiply to negative 18? Well, we have the factors of 18, 1 and 18, but they don't add up to 7. 2 and 9. Well, 2 plus 9 is 11, but 9 minus 2 is 7. So this is the one we're going to use. Now, knowing that it's 2 and 9, you have to remember that they multiply to a negative and add to a positive. So if you have 2 and 9, the only way that you're going to add them so that it's positive 7 is if the 9 is positive and the 2 is negative. And those multiply to negative 18. Now, these are the expansion of the middle term. So that means that this is negative 2x plus 9x. And then you rewrite the negative 3, and you rewrite the 6x squared. And then you remember that to factor a 4-term expression, you do what we call grouping. Group, group, factor. So I'm going to group the first two, group the last two, and then factor those independently, GCFing. What can I factor out of 6x squared and negative 2x? 2x. What's left? 3x minus 1. What can I factor out of 9x and negative 3? 3. What's left? 3x minus 1. And then you realize that you have a common factor of the parentheses, which is 3x minus 1. And when you factor that out, you are then left with 2x plus 3. So what you have done in this process is taken the original quadratic trinomial where the a is more than 1. So you can't just say x and x for the parentheses. You know that there's got to be some coefficients. You have expanded this out backwards from FOIL. And so to expand the middle term, you do product of AC, what numbers multiply to whatever a times c is, in this case negative 18, that sum to b, that add to 7. You list your factors, choose the correct one, try to figure out your signs, and then those factors are the expansion of the middle term, so that then you can group, and factor. So product of AC, sum of b. Let's look at this one. I need to factor a quadratic trinomial, and I know that the factor has a coefficient that's more than just x. So the product of AC, so a is 4 and c is negative 5. So that means that the product has to be negative 20. That adds to b, which is 8. Well, let's think of all the factors. Numbers that multiply to negative 20. 1 and 20, but they would add up to 21 or 19 if it's positive and negative. 2 and 10 would add up to 12 or 8 because there's a difference of 8, so it's got to be this one. Now you want to multiply to a negative and add to a positive. So that means that the bigger one has to be positive. So it's going to be negative 2 and positive 10. These are the expansion of the middle term. So in this case, So I go through this a little bit differently than the notes you might have seen or you might have. So just so you know, make sure that you realize that this is different. Down here, this is different than what you have on your notes. So you use these factors to expand out the middle term. So if I look at the original quadratic trinomial, I have 4x squared plus 8x minus 5. I am going to expand out the middle term by using the factors negative 2 and positive 10. So it's going to be negative 2x plus 10x. Now, some of you guys might ask, does it matter what order you place them in? And the answer is no, not really. If you want to always try to think about where you're putting them, you should put the factors next to numbers that they have the most in common. So for example, if I would have put 10 here, it wouldn't have had a much more than 2 in common with 4, but 10 and 5 have a larger number in common. But if you forget that and you put them in any other order, it's still going to work out as long as you're continuing to factor out all the way. So once you expand out the middle term, you are going to factor by grouping. So if I had the 4x squared minus 2x plus 10x minus 5, I'm going to group the front two, group the back two, and factor. The GCF of the first is 2x. I'm left with 2x minus 1. GCF of 10 and negative 5 is 5. Make sure you write that positive sign there. And then you're left with 2x minus 1. And then what's left is I factor out the 2x minus 1 from both of these. And I'm left with the other binomial of 2x plus 5. Remember, you're looking for factors. So things that are left are being multiplied. There's no addition or subtraction left here. And then you could always check your work by foiling. So first times first is 4x squared. Outer times outer is 10x. Inner times inner is negative 2x. Last times last is negative 5. Combine the middle terms, and you get 4x squared plus 8x minus 5, which is the same as what I had to begin with here. Let's try the next one. Factor, all right. 3x squared minus 11x plus 10. So product of 3 times 10, so it has to multiply product of AC to 30, and sum of B, and B happens to be negative 11. So think of all the factors of 30. 1 and 30, no possible way it's going to add up to 11 or negative 11, I mean. 2 and 15, well, they would add up to 17 or subtract to 13. 3 and 10, they would add up to 30 or subtract to 7, right? They would add up to 30 or 7. These would add up to 17 or 13, 31 or 29. 4, no, it doesn't go into 30. 5 and 6, they would add up to 11. Ooh, that's what I'm looking for. So 5 and 6. Now you want to add to a positive. You want to add to a negative and multiply to a positive. You want to multiply to a positive. That means they both have to be negative. So we're going to expand out the middle term. So this is going to become 3x squared, and again, minus 5x, minus 11x, minus 6x, and then plus 10. Now, some of you might have said, well, it would have been better to put the 6 with the 3 and the 5 with the 10. Absolutely, that's probably better to do. However, I'm going to keep it this way so that you could see what happens if you didn't. So now I am going to group, factor by grouping, group the front two, group the back two, and factor. I can factor only an x out of the first binomial. I'm left with 3x minus 5. There's a leading coefficient in the second binomial that is negative. The greatest common factor of negative 6 and 10, there's a leading coefficient that's negative, so negative 2. And what am I left with if I factor it out? 3x minus 5. Now you've got the common factor of 3x minus 5 and the remaining binomial, when you factor that out, of x minus 2. And you could check your work again. If you wanted to check your work, you could say, all right, let's see. First times first is 3x squared. Outer times outer is negative 6x. Inner times inner is negative 5x. Last times last is positive 10. 3x squared minus 11x plus 10 is correct. So I know that that's my factored form. Let's look at the next one. Product of AC, and sum of B. So multiply to 24, positive 24, that sums to 11, positive. Factors of 24, 1 and 24, no, they're not going to give me 11. 2 and 12 would give me 14 or 10, not 11. 3 times 8, oh, that would give me 11, so it's this one. They want to multiply to a positive and add to a positive, so that means that they're both positive, so it's positive 3 and positive 8. That is the expansion of the middle term. 2x squared, expand out the 11x, so that's plus 3x plus 8x plus 12. Factor by grouping, group, factor out the x, you're left with 2x plus 3. Factor out 4 from those two 8x and 12 terms, and you're left with 2x plus 3. A common factor is 2x plus 3, so I factor that out, and I'm left with x plus 4. Always check your work to see that you did it correctly. First times first, outer times outer, plus 8x, inner times inner, plus 3x, last times last, positive 12. Together, that combines the middle term, and it's the same as the original, so I know that's the factor. So what you're going to do is the same thing. I recommend that when you're doing the factoring of quadratic trinomials, you do some sort of a chart like product of AC, sum of B, where you are making the lists of what you're multiplying and what you're needing to add to. So for example, in this one, you want it to multiply to positive 42 and add to positive 17. And then when you list the factors, don't forget the factor of 1. 1 and 42, for example. Even though in this example that's not the answer, it is very important that you also remember the factor 1 times, because sometimes the sum is going to be that one simple factor. So go ahead and do this and complete the independent practice. When you get to this question here, remember that when there's a leading coefficient that's negative, you first have to GCF and take out the -1. When you have big numbers like these, try to find the greatest common factor first. It's very important to do that. So for example, here, you look to see if 64, 28, and 15 are divisible by anything together. And it does not appear to be. There's going to be big numbers, but you have calculators, so please use them wisely. Make sure you ask for questions if you have.